right around 1 thou, which is actually too tight. If you've never seen this before, it's literally a tiny little strip of plastic, I guess, because pushing these clips into this groove is a struggle. Welcome back to my dream engine build for my dream car. This is my 1998 Integra Type R, and it has a bone stock B18C5 in it, running perfectly well after 272,000 kilometers. And I'm going to do the unthinkable. That's right, everybody. I'm going to pull that motor out, and I'm going to build a B20 VTEC. We're going to make a whole bunch of horsepower with it, we think, but we're also building it ourselves. So am I building what's going to be a very expensive paperweight, or am I going to build the best engine in the world? This dream engine build is made possible through a partnership with HP Academy, who many of you will already know offer courses for all kinds of subjects related to building your dream project car or a race car. Obviously, we're going to be leaning very heavily on their engine building courses, and they do offer 2 of those. They have their engine building fundamentals course, which, as the name implies, goes over the fundamentals of how to go about building your own engine, including how to use the tools, but also like how to talk to your machinist, how to find the right machine shop. And then they have a second course called their practical engine building course, which we're going to be leaning on very heavily here. And that really walks you through how to build an engine in a very step-by-step process. As a matter of fact, they have a 10-step process that we're going to follow, and we're going to walk you through that process in this video. And we've already done steps 1 through 3, which include initial preparation, like ordering all the parts, getting the engine out to the machinist, that sort of thing. Step 2 is stripping and inspecting your donor engine, which we've obviously done as well. And step 3 is your engine machining. So taking the engine to the machine shop, getting that all done. So that means we are now at step 4, block preparation. So the first step that Andre explains here in block preparation is to clean the threads, and most importantly, the head stud threads. Put a little cutting oil on it first, and then we are going to very gently chase the threads in all of these head stud holes.
We should mention, DP, why we have such an extension. People wonder.
That's true.
What's going on
this
here?
This is a weird jerry rig setup, isn't it? Yeah, the tap on the tool up here isn't long enough to reach deep down into this hole, and to get the tap all the way to the bottom, we needed to get a little creative. Just using our maximum ratcheting tool here, and yeah, it looks like I'm at the bottom. Tap comes out, and wow, that's very clean. I mean, you can see a tiny bit of debris in the channel there, but overall, this is clean, so good sign. Now that I've cleaned all the threads, I am going to clean the holes out, and for that, again, as per HP Academy's process, you just blast it with some brake clean, and then clean that out with some forced air, and I'm just putting a rag over it so I don't get a face full of brake clean here. With block preparation complete, we are moving on to step 5 of HP Academy's 10-step process, and that is parts balancing. For that, we're going to start with the pistons, and I've already weighed the wrist pins, the clips, and the ring sets, and they all weigh the same. So the only variation we're going to see is actually in the pistons themselves. Now that we've weighed all the pistons, we know we need to take a couple of tenths of grams off of them so that they're all the same weight in the end. And to do that, I've been watching Andre's video on piston balancing, and what he's recommending is just very gently removing material from this inner lip here. This is an area where you can afford to take some metal off without compromising the structural integrity of the piston. As you just saw, we balanced out all 4 pistons to the same number, and that was only a few tenths of a gram difference there. And to be honest, I don't really know how big a difference that will make in the operation of the engine, but as Andre from HP Academy points out, the better you balance the engine, the smoother it's going to operate, the lower the NVH is going to be, and the less the stress is going to be placed on all the internal components. Moving on to the Manley rods, and there is a way that you can balance these, as Andre at HP Academy shows you how to do, although he has a professional rig that mounts this both on the big end and the small end, and it gives you a big end weight and a small end weight. And Manley actually provides you with data for the total weight, the big end and the small end weight, not only overall, but on each box. You can see there is a big end weight on the bottom of the box and a small end weight on the top of the box there. So we know the big end and small end weights, but without that jig, we have no accurate way of doing it. So I'm not stressed about not balancing these perfectly. They're still very close, and we'll have a nicely balanced set overall. Moving on to step 6 in the process is cleaning all your engine components and cleaning anything in the block that you haven't cleaned already. And as you can see, these components all come out of the box remarkably clean, but on this one Manley rod, we've got a little bit of dirt on the small end here and a little bit of dirt in the bore. You can see on these lint-free clean room towels I ordered, there is some dirt coming off of them. So we're gonna clean everything thoroughly. With the engine and engine components double and triple cleaned, we are ready to move on to step 7, which is assembling the short block. But before you get excited that we're just gonna slap all that in the block, no, there's a lot of meticulous measuring that has to happen using Mike and a bore gauge so that we can check our bearing clearances. Just following HP Academy's process for measuring bearing clearances here. To start off with a mic like this where you measure the crank journal for the big end of the rods. So now with our bore gauge in there, we want to just wiggle it back and forth to see where it zeroes out. That looks like it's sitting on the zero nicely there. Now we need to install our king bearings into the rods here. When installing these bearings, Andre points out that if I just push it down now, it's going to scrape the back of the bearing and potentially put some debris into the bearing. So you want to push it toward the other side so that it's not digging into the back side of the bearing when you install it. So you can see I just sort of snap it down in there and do the same on the top side. So now we use our bore scope in this rod with the bearings installed to see what our clearance is. You want to measure the vertical clearance, so along the top and the bottom of the rod, not the sides. We are right around 1 thou, which is actually too tight. The factory clearance for B18C motors is 13 thou to 20 thou, and honestly I'd rather be on the looser side of that if I could be. A good way to sanity check your measurements is to use Plastigauge, which is a very simple way of measuring clearances. If you've never seen this before, it's literally a tiny little strip of plastic, I guess, that then when you clamp the rod and bearing onto it, it squishes down a specific amount, which you then measure on this scale, and it tells you what your clearance is. And interestingly enough, the Honda factory service manual actually specifies using Plastigauge to check your bearing clearances when rebuilding a B18 motor like this. So we're going to check this just to make sure that my use of the bore scope was accurate. So with the mic method, I saw right around 1 thou of clearance, and with the Plastigauge, I am seeing basically the exact same thing. The shop manual shows 1.3 to 1.7, as the spec clearance for this crankshaft. Interestingly enough, we are seeing very comparable results with the mic and the plastic gauge. So I think this kind of like confirms that plastic gauge is actually not a bad method if you don't want to go and spend hundreds of dollars on all these specialized tools. You can, I think, get a very good measurement of your bearing clearances with plastic gauge, which costs about $7. So having clearances out of spec is not that difficult a fix. You just need to have bearings in an oversized in stock, which we do not have. So we are going to now order the oversized bearings, and that will fix this problem, which we will show you shortly once we have those bearings on hand. So we just checked all of our clearances with both the mics and the plastic gauge method. And interestingly, on the crank, we are measuring more like 2 thou on the nose with the plastic gauge and more like 2.4, 2.5 on the mics. And that may just come down to my inexperience with using the mics and how I'm setting them on the crank journals. Like maybe I'm not setting them tight enough on the journals. Frankly, I trust the plastic gauge more than I trust myself, given my inexperience with these tools. But this is a great way to, like I said before, sort of sanity check your work with the mics and just see that you're in the correct ballpark. And we're certainly in the correct ballpark. In fact, at 2 thou, we're right at the limit of the factory recommended specification. But even looser than that, say at the 2.4 to 2.5 that I was seeing with the mics, that's still a really nice place to be on the main bearings, because being a little on the loose on the mains means you've got more oil flow going to the rod journals, and that's never a bad thing. By the way, this is a stock B20B crankshaft that came in this block. It's not been machined, not been micro-polished. Eric Levine from Levine Motorsport just gave it an inspection and gave it an okay. In his experience, you're better off not touching the crank. You don't want to machine it if you can avoid it. You just get better reliability out that way. All right, while we wait for those oversized bearings, we are going to move on to checking our piston to bore clearance and then setting our ring end gaps. As CP Piston specifies on their data sheet here, that we need to measure the diameter of the piston a 1/2 inch up from the bottom of the skirt. So we've gone ahead and marked that point just with a little Sharpie mark on both sides of the skirt. And now we will take that diameter measurement and we'll transfer that onto the bore gauge. So we're just checking the bore clearance here on cylinder number 1, and it is spot on. It is right at the 3 thou that CP Piston specifies. So it means the machine shop did their job perfectly, because that is right on the money. Moving on to setting ring end gap, and for the top ring, Levina Motorsports has given us a spec of 17 thou, and for the second ring, he's given us a spec of 22 thou. Starting with the top ring, we just put it in the cylinder like this, and then we set it to a consistent depth just using an old piston. As you can see, I've left the oil control ring, the bottom ring, on here to stop it from going any further into the cylinder, so this will just give me a nice, consistent and square way to set the ring at a consistent depth. I can tell by eye that I'm not anywhere close, like this won't come anywhere close to fitting in that very tight gap. So we've got to now grind that down a fair bit. One of the tips that Andre gives you is to make sure that you only grind on one side, because that will help keep the gap even. And you want to grind from the outside to the inside of the ring, keeping nice consistent pressure against this dowel so that the ring's not flapping around. I know from having done the other 3 cylinders already, I've got a fair ways to go, so I'll give this 7 or 8 turns and I'll remeasure. You can tell we're still a long way off here. And one last step you do want to take is to make sure that you get any little burrs or pieces off of the ground edge. You don't want to leave those there, so I just come in with a very fine file here and just touch up any of the edges that I see that might have a little bit of a burr on it. Oh, like butter, like butter. So there you go, top ring done. We'll repeat that process on the second ring, just to that 22 thou spec. Our oversized King XPC bearings have arrived, and that means we're going to now adjust the bearing clearances on our rods before we proceed further with the short block assembly. So we've put in the lower bearing shell on this number 1 rod to take it from 1.7 up to around 2.2, and you can see we are right there, just a hair over 2 thou clearance, which is exactly where we want to be on these. Manley actually specifies 2 thou clearance, even though that's the upper range in the Honda manual. We've already done the other 3, as I mentioned, 3 and 4 right at 2 thou, and number 2 is just a hair over 2 thou like this one. It is time to put these C-clips into the pistons and then the rods into the pistons. And as you can see, I've put some like cloth tape on my thumb, because pushing these clips into this groove is a struggle, and it was destroying my thumb. But as you can see, I kind of get it started in the groove there on one end, and then I compress it as much as I can with my thumb, and then I have to come in with a flathead screwdriver and kind of pry on it. Okay, so that's started, and now I just kind of work it down into the groove here with a little bit of pressure. There it goes. So it is now in that groove. That is side number 1. Now we put the wrist pin, which is lubricated with engine assembly grease, and it'll hit on that clip on the other side, which sets it in place. Okay, there she goes. All right, we are in. We'll give this a really close look to make sure that clip is in there, because if that comes out, you're gonna have a bad day. Time to install the rings. I've already done it on the first 3, so some practice runs have been done. There is an actual way to orient these rings, and we'll start with the oil expander ring, which is this guy here. And as he points out in the video, you can see where the split is. You actually want where it ends to be pointing down, the way they are in this position, rather than pointing up like this. So we'll put it on this way, pointing down, and this gap is meant, as you can see on the diagram, to be over on this side. Not super precise, just sort of in this 1/3 of the diameter of the ring over on the right side. So I'll set it over there. Next up, I'll put on the bottom ring for this oil expander, and these are very flexible, so you don't have to be too concerned about it, but I find the best way to do it is just start it underneath and then just wrap it around. And there you go. Next up, I'll put the second ring on, which is your oil scraper ring, which has that interesting little sort of hooked profile out on the outer lip here, which helps scrape oil off the cylinder walls. And there is actually a top and a bottom to this. There is a spreader tool you can use, but Andre shows you in the video how you can just kind of use your thumbs like this, spread it open enough to clear the diameter, and then just sort of slowly work it down into that second gap. Same process here, I'm just making sure I've got the marking on the top. I've got the gap on the side of the piston I want it on. Just gently spread them, and there you go.
Easiest job yet, or what?
It is the easiest job yet, yeah. You just have to pay attention, basically. And this basically concludes step 7 of HP Academy's 10-step process, that is assembling the short block. Obviously there's some details that we could put on here, like the front seal and the oil pump and the oil pan, but this is the end of the difficult part, the part where you would really want access to a course like HP Academy's. Let me know in the comments, guys, if you find it inspiring to see a relative novice, I've only built a couple of engines before, putting an engine together like this. Does it take away some of your own fear about whether you would tackle a project like this or not? Or does seeing me do this scare you even more the way I think maybe it scares Peter? It's weird because Peter's actually very detail oriented, his OCD is famous, but I can hear his stress level rising in the background anytime we do an engine build. And yet for me, I find it a very zen process. I like the slowness of it, I like the methodical measuring and the pace of it. For me, I actually find therapeutic. And there you have it, the basis of our B20 VTEC engine that we think is gonna make 250, maybe even 260 wheel horsepower on the dyno. You can convert that to, say, 300 crank horsepower. This car makes 195 crank horsepower, so we have added, or we hope to be adding, a whole bunch of power to this car and spicing it up quite a lot. But in the next one, we will obviously build out that long block, put the cylinder head on, take that motor out so we can put some of the accessories on here and get it ready to go back in the car. So thank you guys very much for watching. And of course, thank you HP Academy for all your support. Make sure you guys go and check out hpacademy.com and check out the description below for that discount code.